Hello, let's check this. Okay, looks like we're working. So this is our tea experiment. This is our first measurement here. And as we can see, at 77 degrees, it was 80 degrees, but -3 because our thermometer is off by 3 degrees. We can see at 15 seconds, we get this weird bump in our measurement here on the blue curve. Then we get a bump at 30 seconds on the red curve, and then it starts to saturate. If we look up between 500 and 550, which is where we agreed that we would look for the brownness, because it doesn't saturate, it doesn't go off scale, even after quite a long time. We can see even after 10 minutes, 600 seconds is 10 minutes, we get a measurement. It's overloading at about 410 nanometers. If we change the temperature to a higher temperature, so this is 77 degrees, this is 85 degrees, we can see the increase is slightly faster, but not massively different and not massively obvious in this way of presenting the data, but we get much the same, and it also cuts off at the top. If we increase it to a third temperature, or actually decrease it to 65 degrees centigrade, I think it is, we get this measurement where they're somewhat lower. So if we compare that one with the one before, look at the red curve, bong, that's at 80 something, 85, just over 1.5, and at 65 it's less than half of that after 30 seconds. You can also see the first one at 15 seconds is way lower and lower than the first one that we did, although it's not very well following a trend, but we will see later when we measure the caffeine, because that peak is probably mostly caffeine. If we look in the higher range, we see much the same thing happens. It goes up and eventually saturates. I've measured it for 900 seconds here because I was expecting it to take longer because we're at a lower temperature. So if we go here and try to fit the data, so what I've done here is taken only one point at 525 nanometers instead of doing the complicated thing that I was going to do. That's just to get some preliminary data. So this is my curve. You can see to start with, it goes fairly constant, possibly down. So this is 15 seconds, this is 30 seconds. Oh, sorry, I can't point, can I? So on the top left of these diagrams, you can see the points, all of the points, they go across and down. So the first point is 15 seconds, the second point is 30 seconds, and that's going down very slightly, and then it goes up in a smooth curve. If I try to fit that with a log curve, it doesn't fit very well. You can see the last point isn't fitting, the first point isn't fitting, and the middle point isn't fitting either, so that's rubbish. What I did was I deleted the first 2 points, I think, and fit the rest of the curve, assuming that something odd is happening at the beginning, because the water maybe is getting through the tea bag or something. Anyway, it's not a smooth curve, so obviously we can't fit it with a smooth curve, so it's reasonable to get rid of those points at least for the fit. And then we can have a look and see what happens, and we can see it does follow very well, even the last point is on, so we could have this log curve, which is shown on the diagram at the bottom left there, and at the top with this red curve on the right. That's a different equation, which I've tried to fit with a different way of fitting it. That would be solver, and that is an exponential type equation. You can see it's not quite as good a fit, actually. An exponential fit is what I would expect. So an exponential decay is what I would expect, but it's not what we see. We see more this log behavior, because it does appear to be still going up fairly significantly. The advantage of the exponential is that it would give us a value at infinity mathematically for where it will go if we waited forever. If we look at these curves for all 3 temperatures, we would get this result. So this is just the 3 curves with the first 2 points cut off and fit with a log curve. You can see the coldest temperature, 65 degrees, is not fitting as well. It's going beyond it, so it's probably not this type of curve, and we're going to have to look at that more closely. We can also see the highest temperature is also not fitting it, and so it was just chance that I'd taken 77 degrees, which happens to fit. That happens sometimes. Also, we will need to take the average of a few points, because it might just be that these ones at 525 nanometers are not a very good measurement of the average, but we can do that as well. So what we're going to do is fit these data. I will upload the data onto Moodle. You can fit the data using whatever you feel like. Excel is quite good at doing it. If you've got Solver, then you can fit it to a log curve, or preferably a different type of curve, and we can see if we can get it to fit. You can look up what types of curve we would expect to have. I couldn't do that at the time because there wasn't any internet. And then we can fit them, and then we can generate a three-dimensional diagram in temperature, time, and brownness ratio, which in this case is just absorbance. But we could set it compared to one of the values. What we can see here is, unfortunately, that we don't have the same endpoint. So if we waited forever, we wouldn't expect these curves to reach the same point, or not very obviously to, because we don't have enough data. But we can see they are curving off, but we probably can't see where they're going to get to. Somewhere around 0.6, maybe 0.55 probably. But it's a little bit hard to tell. No, it's a lot hard to tell. So that shows that I probably should have measured it for longer. That might be something to do with the last set of measurements, but the first thing that I'm going to do is measure the caffeine concentration when I get back into lab. That is the best thing to do with those samples at the moment. So what I've done is I've measured the brownness, because I knew that it would oxidize and go darker over time, and that would be very difficult then to correlate back to the brownness ratio. So I've just measured them very quickly so that we've got that data. Then I'm going to extract the caffeine from the samples and try to get the same type of curves for caffeine amount. We will also have to do a reference using some caffeine, and then we will be able to write it up, which is the job that I'm giving to you for this course.